Welcome. In this lesson, we are going to learn about control flow and we are going to take a deep dive into Python's implementation of it and what it means generally. So, what is control flow? Control flow in Python really refers to the order, excuse me. Right. So, control flow in Python refers to the order in which individual statements or instructions that were given to the engine are executed during like the program's runtime. So control flow refers to um, in which the order in which individual statements executes during the program's runtime. Executes during the program's runtime. Right. So usually the entire the programs that we've been writing since we started this series, they are all, line by line, and every single line gets executed. But in some cases, and majority of cases actually, that is not the way things happen. So in some cases, we have to, we don't want to like evaluate every single part of the code. And it is something that comes every single part of the program, and it's something that comes up in Python um, every time. Usually, sometimes you do not want to like evaluate every part of the program. Sometimes you want to keep re-evaluating a particular part of the program. Like we want to keep doing that thing over and over and over again. So that is what Python helps us to do. And Python has three main implementation for uh, control flow. So say types, and our types here, types, control flow, and number one, which we're going to be covering extensively today, is conditionals, the if else. Part two is the loops, right? So you can think of for loop, while loop, all of those stuff, all of those stuff like that. So if we want to split this into two, we'd say Python has two, or if we want to like, we'll say Python has three, but if we want to like just say for loop, then while loop. There are two types of loop. So we can see two. So in this particular session, we are going to be covering conditionals. Conditionals. Yeah. So let's see how it works. So let me put control flow one. I just in here put conditionals here. Perfect. So let's get into it. So what's conditionals really? So conditionals in Python, or even generally across every programming language, is our way of writing a program that makes selective decision. So what happens is we look at our um, code and we'll be like, okay, if this thing is true, do this. Else, do this other thing. So what does that mean? Let me come here and add a new question here, then we can go conditionals like this. Great. So the um the component of a conditionals, like all of the things that you would find in a conditionals are, you would find the if statement, the else statement, and the elif statement. The if statement, the else statement, and the elif statement. So we can go if, we can just add this if, else, and elif. And these are the three um, keywords that you would find in a conditional. And the way it works is we usually start the flow of the condition, then occurs usually this occurs at the end of the flow, and always after if or elif. So else will usually come after if, or in the case where we have elif, then we are going to have else after that if we want. It is not extremely important. Not important unless needed. So elif occurs in after if, occurs after if and before else. It is also not important unless needed. So that means we can just have if else, or we can have if elif without else, or we can have if elif else, any which one. So let's look at a very simple example. So we can say write a program that checks if students passed a course or failed just by accepting their score. So we can go pass mark is 50. So how does that work? We are going to say, firstly we accept their score. So we say score is going to be equals to, we can go int input, or in the case where we have float score, so we can go float input, then we can go enter your score. And once they provide their score, the next thing we want to do is we want to check that particular score and see if it is greater than 50 or not. Then we can say, we can say if score is greater than 50, then we end it with a semicolon. This is important. So we go if, then we pass in our check. That thing I want to check, we'll pass it in, and we go, okay, if this thing is true, then we end it with a colon, and we go to the next line, and it is going to give us this space here. It's not going to take this thing back. And one thing that I've found with beginners, especially people that are just starting out, is that they tend to like backspace this and take it back to this. You should never do that. Python has given you the perfect place to Collab has given you the perfect place to be. So if you've done that, you should just go all the way back up, press enter. Just what you have to do is make sure you have your colon here, then enter, and it is going to put it in the perfect position. We call this thing indentation. And the way Python understands the structure of a control flow generally is with indentation. So we say if score is greater than 50, then what should happen? So if this condition is true, step into this indented block, this block here. So what should happen if square is greater than 50? Well, we should print say you have passed the course. So pass mark is 50. So anybody that scored 50 also has passed. So it's greater than or equals to 50. Then you can come here and say else. Since this is binary, this situation is binary. It's either you've passed or you failed. So you say else print you failed the course. Great. So we can give this a spin and see if it works. We run this. I still connecting. This is our first program today. And once it is done, we are going to be up. Yeah, it's done. So let's try out 55. It says you have passed the course because this line executes. Then if we pass in 31, says you have failed the course because this line is what gets executed. So that's basically uh you know a very simple implementation of a binary excuse me, of a binary condition. Binary condition is where you have something to be true and then another thing to be false. Like, do you understand? And you can have situations where um let's add binary condition situation. So this is like a situation where you expect two outputs. In some cases, you expect just you only care about one output. In this case, you are saying this or that. Sometimes it's just this, and you are not interested in that. Like it's just this. And an example of that is going to be something like let's write the program that checks if a number. Let's check. Okay, that checks if a user is eligible for an offer. Only teenagers are eligible. So once we write the program that checks if a user is eligible for an offer and only teenagers are eligible. So we want to accept age. We say age equals int. Age is always going to be an integer. So you say age equals int input. And I'm going to say enter your age. Then here. Now, what I want to show you is this. We could just do if age is greater than 12. That's one condition. And, we can use logical operator to tie multiple things together. And age less than 20. What should happen? Print f string. You are eligible. Meaning that what? Meaning that if somebody is between the ages of 13 and 19 inclusive, so we print you are eligible. And then we are not interested in, oh, what if they are less than 12? We don't want to say you are ineligible. The only thing we want to print is you are eligible for those people that satisfy the criteria. So this is my attempt at showing you that you can only have a conditional that just has an if alone. Only that it has is if. So if I run this and I go, let's go for somebody that is not eligible. So 57 is not going to do anything. It's just going to run silently because we don't care, right? In some situations, you actually do not care. So if we run this again, and we do 16, it says you are eligible. So the reason why it does not print anything for anybody that is not a teenager is because we didn't make provision for that. We didn't like make any provision for that. So that is the reason, right? So this is a case where you are tracking just one condition. So we're going to say single condition situation, right? And another thing is let's check situation. Let's write a new program. Write a program that checks whether a user is a child, teenager, adult, or old. Now we have multiple conditions here. We have child, teenager, adult, or old. So how do we do that? We're going to say age, and this is a case of multiple conditions. So we say age equals int input, and we enter your age, and we can come here and say if age is less than um was that if age is less than 12, then can print string child, then elif, that is else if, which is like an intermediate condition, a condition within if and else. So we say if, and it takes a check too. You have to pass in something to check there. And say if age is less than 20, so this should be less than 13, not 12. So if age is less than 20, we'll print teenager. Then another elif again. So we can have multiple elifs. So we say elif age less than, I don't know, let's say 50, print adult. Then here I can say else, which is the final thing here. Final thing here we say print. So else does not take, as you've seen here, else does not take like an expression like this. That's because, and this is the perfect way of explaining it. You're asking if the age of the person is less than 13, they are a child. The age of the person is less than 20, they are a teenager. If it is less than 50, an adult. Anything else that remains after we've checked all of these things and the age does not satisfy it, then that is old. Right. So if I should run this and go 59, it says old because 59 does not satisfy this. Neither did it satisfy this. Neither did it satisfy this. It only comes in this else. 59 is not less than 50. It is not less than 20. It is not less than 13. So it is going to be in the else. Right. Now, let's check for other ones is we can go 11. So it says you're a child because this executes. Then we can go 18 and it says teenager. And if you go 45, it's going to do that. So, and the way this works, and that is even the reason why this overlap, because you know, I'm saying, well, if it is less than 20, this is less than 13. So is there not going to be an overlap? So what happens is this guy tries to execute like from top down, and the very, very first one that fulfills the condition is what it executes. So it checks is 13 um is age less than is 18 less than 13? Nope. Is 18 less than 20? Yes. It executes this. So the moment it executes this, even though 18 is less than 50, it will not get here. It has already executed this and escape the stuff. So that means if you have something that you want to repeat, what do I mean? It means that this is only going to be applicable for mutually exclusive situations. If you want to check something, for example, what do I mean by mutually exclusive situation? Somebody cannot be 18 and be 25 at the same time. So, but let's say you want to check something that has the potential to be mutually exclusive, like to be mutually inexclusive, like can two things can like exist. So in that case, what you want to do is you want to use multiple ifs. Let me show you what I mean. So let's say we want to write a program that checks if a number is even, odd, or prime. So in this case, if we start with because normally a number can be odd and prime at the same time. I think two is even and prime. So to write that prime, we'll need to have for loop working, and we haven't really got into for loop. So let's do if a number is even, odd, and or a multiple of maybe four, multiple of four. So we're going to say number equals in int input, enter your number. And what do we excuse me, what do we get in this case? What we are going to get out of this is we are going to say if number modulus 2 equals 0, that is, if we try to divide 2 by our number and there is no reminder, it means the number is print f string number is even. Then let's just do the incorrect thing first, then you see why it is incorrect. Say if number modulus 2 equals 1, that is going to be print f string number is odd. Then we can say elif, because if we do else here, it is going to say every number in this word is a multiple of 4. For example, let me show you this. Else, then else does not take a condition, then we go print f string, and this is wrong currently, but I'm going to show you why it is wrong. Number is a multiple of 4. So let's run this. First problem is if we come here and pass in 57, for example, in this implementation that we have, this guy is never going to get executed. There's no number in this world except maybe for 0, I think. But even 0 will get executed here because it's going to say even, because 0 modulus 2 is going to be 0. So if we say 0, it's going to say even, yeah, like I said. So there is really no number that you can pass in that is going to make this execute ever. And the reason is because a number in maths that is a real number, will always either be even or odd, one of the two. Now, it means this is never going to get executed. And what's the problem with that? The problem with that is we are never really going to get this kind of execution where we want to see, for example, if we pass in 12, you should say 12 is even, and also 12 is a multiple of 4. So it means that this particular implementation here is never going to work. So we need to edit, and the reason why it's never going to work is because, like I said earlier, this is a structure for mutually exclusive condition. So this is true. I am not going to check this. For example, if I should run 12 and enter, it doesn't say 12 is even. Although 12 is even, 12 is also a multiple of 4, but it is not even getting to this part. So how can we fix that? The way to fix that is to use if all through. And in the case of multiple if, Control Z. So we use if all through. So we say if number modulus 2 is odd, then here also is going to be if number modulus 4 is equal 0, then print this. So we should run this again, and we have 12. It says 12 is even, 12 is a multiple of 4. So this executed, what's happening? This executed, went down again, checked if this is true, it is not, moved past it, then this also executed. So this is a way to check. So whenever you want to check things that are mutually inexclusive, they can happen simultaneously, they can happen beside each other, like they can coexist. We use if and if. So that is that. And let's take some final example. We're going to write a program that checks if a student write a program that performs, let's perform a login. So firstly, we're going to start by having our fake database. Let's call it fake underscore database. And inside it, we are going to have some username and password. So let's say Fola, and password is 1234. Wale, password is 4334. And Daniel. And Daniel's password is 120. Now, what we now want to do is we want to set up the login. So what's the first thing that happens? The first thing that happens is we accept the person's username. So you say username equals, then we go input, then we can say enter, or you can just say username like this. Then we can say password. And just to show you that you can put f string anywhere, you can put it inside input also. You can say f string I, username, enter your password. So it is going to go something like if you pass in Wale, it's going to say I Wale, enter your password. Now the next thing for us to do is to actually validate the password. So we want to validate at this level. Let me add a comment here. We can say validate the password. So how do we do that? We're going to say if fake, that is whatever password that they give to us, if fake underscore database of their password equals of their username rather. Whenever I want to access, if you still remember dictionary, whenever I want to access a particular value, we are going to use the key. So if they pass in Fola, so we say if fake database Fola equals the password that they give us, then what do? We allow them in. Say F string access granted, welcome username. So else, so in this case, else will print incorrect password. Right. So let's run this auto trail like a little problems here and there with this particular program, which you are going to see shortly, but it's going to run perfectly. Now let's run this. It says username. Let's pass in Wale, and we're going to firstly try a wrong password. So Wale's password is 334, but we are going to pass in 1234, and it says incorrect password. Then let's try for correct password. So let's use Daniel, and Daniel's password is 120. It says access granted, welcome Daniel, because Daniel's password was correct. Now, let's now pass in a wrong, like a completely wrong user, a user that we do not have. So we're going to say John, we do not have anybody by the name John, and we say we just make up some password for John. Now, what happened? We got an error. This is the issue that I was referring to earlier. We got an error, and the error is that, well, there is nobody with the name John inside our database, and it throws an error. So we should undo that. How do we undo that? That brings us to the concept of nested ifs. So let me put it here and say nested ifs. Nested ifs. Although in practice, before you consider nested ifs for something like that, in practice actually you would use nested if for something like this, but nested if is not a way of fixing error. That is exception handling, error handling, which is another topic that we're going to get to in this particular playlist. But nested if applies here. It applies in the fact that, well, before we even start checking whether somebody's password is correct, the first thing to check is whether they are even a user, whether we have them in database. So what do? This if statement here, we are going to wrap it inside a larger if. So we are going to start by checking the user. We check if the user exists. And nested if is if within another if. So we're going to have one large if, and we say if um username not in, that is, we cannot find username inside fake, sorry, fake underscore database dot keys. Don't forget this here, Folawale, Daniel, they are the keys, and 1 2 3 4, all the password, they are the values. So if we cannot find username in this place, we are going to print user not found. Then else, that is, if we can actually find the user, we do all of this. So we tab this in. So what do we have? Inside here, we have an if statement within another if block, like another if statement. You know, we have our if here that does something. Well, then if that thing is not true, we go into the else block. Now, inside the else block, we now do that. And why did we use if else? The reason why we use if else is because this is a binary domain. It's either you are a user or not a user. There is no in between. So we are saying, okay, if you are not a user, we'll say user not found. If you are a user, that is, you exist in the else block, then we validate your password and all of that. So let's run this again. And firstly, do somebody that doesn't exist. So let's do John again. And it says, I, John, enter your password. And we go 1, 2, 3, 4. And it says user not found. So probably another thing that you want to do to make this nicer is before you accept somebody's password at all, you want to check whether they are a user or not. So let's remove the password line here and put it in here. So we accept the password here after we've confirmed that they are a user. So what are we going to do? Let's say John again, and it says user not found directly without saying enter your password. And that's the whole idea behind flow control, like the way we have this opportunity to control the execution of things, the way we want things to execute, the way we want things to go one by one. So if I come back here now and say uh, Wale, and I pass in password as, what is Wale's password again? 334. It's going to say access granted. Welcome, Wale. And that is basically if statement for you. We've been able to cover binary condition, single condition, multiple condition. We've looked at what mutually exclusive condition means. We've looked at mutually inexclusive conditions. And finally, we also look at nested if situations where you have if inside another if. You can have as many of them, one if inside another. But the bad idea, you should really not go beyond two nested ifs, really. Anything that requires you to do more than two, more than three nested ifs, there is always going to be a better way to handle it. So that is um conditionals for you. As we proceed, you're going to be seeing more application of it, but this is an introduction to conditionals. Thank you for tuning in. See you in the next one.